Hello, everyone. Oh, yeah. Welcome to tonight's Foresight Live event on Convergence of Critical Technologies in AI and Telecoms. Thank you very much for coming out to the engine shed. Look forward to this conversation. My name is Thierry Heles. I work with Bristol Innovations. And I've got a wonderful panel here that I'm going to ask to introduce. Start with anything else, starting maybe with Shadi.
My name is Shadi, and I'm from Smart Lab University of Bristol. I'm lecturer, and my main research area is on AI native network, service orchestration, optimizing the network.
Hello, I'm Dan Warren. I lead the communications research team at Samsung Research UK. Within that team, we have a lot of the topics that Shadi has just described, plus other applications for AI, and we also have our team responsible for standardization in telecoms, participation in GSMA, and intellectual property.
Hi. So my name is Doug Pulley. I'm CTO of RANsemi. We make semiconductors for the RAN. Let's figure out. I'm also chair of the UK TIN AI expert working for telecoms.
Hi, I'm Robert Curran. I'm an analyst with Appledore Research. We're a specialist telecom software consulting and marketing firm, UK and US primarily, in Singapore as well. We focus really on what's happening in the market, where Shadi is to some degree, and trends are changing. Buying what operator buy, either buying from.
Awesome, thank you. I'm going to ask for just a quick show of hands, some audience participation, just to kind of, so we know who's sitting in front of us. If you're working with industry, can you just raise your hand? Okay, quite a few. Investor or funder of some kind? No one? Yeah. And policy, policy making. Cool. Got a couple of people. Yeah, university people. Well, we have the university corner. Awesome. Dan, I'm going to start with you, and then move over to Shadi because you work with Shadi on Reason. Can you tell me a little bit about that collaboration, what it entailed, what Samsung hoped to gain from it, and maybe what it has gained from it?
So Reason was a UK government project funded starting in 2023. The funding concluded in March this year, but has been extended for a further 9 months. So we are carrying on with what we were doing around until the end of this year. And probably the main thing which ties what we did in Samsung to what University of Bristol did with Shadi and Juan, who's jumped the fence and gone elsewhere as well, and a whole range of others, was predominantly around the convergence of exactly what we're talking about today. So we were looking at how to bring AI to the telecoms network to offer benefit. There's a kind of a trope which is developed in telecoms about network for AI and AI for networks, which is fine in as far as it goes. There's a third element on top of it, which is actually how AI is supported by a network as well. But what we tried to do was take those two paradigms of AI for networks, networks for AI, look at how AI can be applied to optimize a network, in some cases in points, but preferably end to end, and then how the network needs to adapt to enable AI to be applied to it. And that's essentially about exposure of data, but it's also about having the right levers for automation to allow an AI to directly make an impact on the network once it concludes something or wants to implement an additional optimization back into the network performance. And so what we benefited from was we did a lot of that. We had a number of pre-existing AI applications for networks, which we brought into the project. We looked at developing within that project a framework within which AI could exist, how it could expose the intent of the AI from the perspective of what the purpose that the AI was trying to optimize against was, and then how you could take lots of AI within a network, mitigate where there was conflicting goals, and then ultimately get something out at the end of it, which was of positive result.
Shadi, I'm going to ask you for your perspective on Reason as well. What did it look like from academia's point of view?
Sure. So, as Dan says, a lot of collaboration was between university and Samsung and other partners as well. So I think we had a very nice collaboration with academia and industry. But in addition to that, so I will mostly focus on the AI orchestration as well as orchestrating the services and improving or optimizing the network performance. In addition to that, I would say in recent projects, sometimes, we had some challenges, a little bit challenges between, of course, university and industry, but I think it went very well, and it resulted into some very nice collaborations, joint collaborations, papers that, we are very in the university. Also, we had some nice other collaborations like the demonstration that we had across the UK, because we had some use cases that, for example, I was a PI of a project that we demonstrated one of the use cases, and we had very nice collaboration in this use case as well. The result was demonstrated in Mobile World Congress, March this year, as well as Connected Future Festival in Bristol, and of course in 3 other cities across the UK. So yeah, it was a very nice collaboration. And as Dan said, so we not only focus on the service management and orchestration, also on the splitting the AI models, orchestrating the AI models, making sure that the performance of network services are fulfilled based on the service level agreements that we had, but also making sure that the performance of AI models are fulfilled as well, and then placing the AI models in the best place that they can have the best performance out of the placement.
I don't think we can talk about Bristol and telecoms without mentioning Joiner. I don't know if Dimitri Semenidou is in the room. I don't think she is. But we have to mention that as well. Can you tell me a little bit about the Joiner project? Because I think you're involved in that as well.
Sure. So the Joiner project, I'm not sure if you are familiar with that, so I try to make it very brief summary of this. So the Joiner platform is a national scale platform that connects now 11 cities across the UK. And it uses the NDFF and the fiber connectivity between the cities. And it's a very nice collaboration between universities and some SMEs as well. And during the recent demonstrations, especially at the Connected Future Festival, so we joined the platform to connect Bristol to London and Cambridge. So the demonstration that we had, we could nicely use the joiner, and then it had very low latency and very nice bandwidth because it uses fiber. And yeah, so do you think if I add any? Yeah. So the next part with the joiner is that joiner has a terminal that, for example, recently some industries were interested to be connected to this joiner platform. The connection is very easy, and then because in joiner there is a joiner terminal, that in this terminal all the management and computing resources are provided through this joiner terminal, and then the connection to the joiner. So it is already that for example, this joiner terminal will be installed in that city or in that industry or even SME, and then they can keep their own privacy network and then connected to this joiner terminal. And through the joiner terminal, they can be connected to the whole joiner and other cities across the UK. This joiner terminal can provide like the management of the network management of the services. For example, you can have a dashboard and that you can say, oh, I want these services, I want these resources, and then the joiner can all the magic at the backup, and then it can be connected. So all these cities, like from the north to the south, and then recently the Ireland will be connected as well. So it will be like between the like UK, South Ireland, and later to the Europe.
Sure, it'll come up again in more detail, and we don't get too technical. Doug, I want to hear from you as well. We kind of had academia, we've had Samsung. What are the current challenges for startups? And I know you're a bit stealthy, so you can't talk quite about the technology, but tell us as much as you can.
Okay, so I think there's I could go on for ages, but I mean, ultimately, I mean, to start with, having such great test beds locally, as a small company looking to expand, just one of the big bottlenecks I think that we perceive in growing as a more AI-oriented company in the RAN is just skills, staff. So I think being local when we are just around the corner, that's a real plus point for us. So we're very happy about all the great things that's going on. I think in terms of in terms of the sort of challenges, I mean, I think we probably take a different or a different complementary view perhaps to some of the challenges being addressed by those projects, in that AI is a very broad church, and you can put lots of different AI and lots of different bits of the network, and we focus on the edge, in specifically in base stations. That's what we do, and clearly there's challenges to integrate or to add AI into those areas. You've got to worry about the cost and the power consumption. It's all very well providing great features if it costs more in the electricity bills and the benefit that you get. So that's very important. I think the difficulty is AI is seen as this. It's all about ChatGPT, and it's all about very, very big GPUs. And actually, that's just one data point on a very large continuum. So I think I think it's important to look at other aspects, and that's what we care about. Distributing AI around the network. Laws of physics say that you have to put certain functions right near to antennas. You can't have them in a data center 30 miles away. So there's a huge opportunity there to build solutions for that. But the important bit is then to make them work well with the rest of the network. You can't end up in a situation where you have put those functions somewhere, but they require this huge infrastructure or elaborate mechanisms to manage them remotely, like some huge umbilical cords. So I think there's a lot of work to do on making these things standalone, autonomous, collaborative, and to not fight with the rest of the network, as I'm sure we'll hear some anecdotes of. So those are the sorts of challenges that we're seeking to address with what we do.
I see Dan nodding quite vigorously, so I'm sure we'll get some strong opinions. You mentioned you're based around the corner. We should perhaps say as well that RANsemi just announced that they will move into the Bristol Innovation Zone, which I think was
we're definitely associated with it. Whether we're necessarily co-locating, I'm not sure. But
I've committed you now.
But no, absolutely. I mean, that's we press release that we're very pleased to be an inaugural member, or whatever the official phrase is, for the reasons that I outlined.
Robert, can you give us the big picture?
Big picture, yeah. So as I mentioned at the start, I kind of come at the other end of the sort of life cycle we've talked about today. and look at what's happening in the market. What are telcos buying? How do they think about AI? Our topic today is the convergence of AI and telecom. And it's kind of interesting. Telecom, as relates to kind of telecom operators that we know and love or don't love so much, has been on just a gradual transition for quite a while now. Initially impacted by cloud and then softwarization of networks, turning the boxes that they used to ship out in vans and wire up in the field into computers that are controlled through software. It's a massive, massive shift. Everything that goes along with that is changing. Now we're being hit in a positive way, I suppose, by AI and some of the concepts that the panelists have talked about here already. Again, another wave of disruption into telcos. And it's quite overwhelming for them because these are big companies that, again, are very proud of their heritage. They think they invented a lot of the modern internet, and it surprised them a little bit for startups and other companies to come in and say, actually, we found a better way of doing this thing that you thought was your bread and butter. So that can be a little challenging. Doug mentioned this skills issue, and that's certainly an issue on telecom companies. If you're a Vodafone or a BT, maybe you have a certain cachet, a certain appeal that you might help you with hiring software engineers and software skilled people. If you're lower than that, you're probably going to struggle, and you're going to have to wait for other vendors that you rely on to catch up. So the good news is there's plenty of opportunity in the field. I think there's an interesting range of opinions when you talk with telcos about AI. Let's just divide it at a very, very simple level into two classes, machine learning and then everything else. Okay, I'll come back to the second class in a moment. Been using machine learning in telecom networks, particularly mobile networks, for ages, for at least a decade. Predictive models to work out performance is like, or how to improve things, and so on. So that's in some ways, this isn't really new, but actually the way in which it's being applied is starting to become much more novel. The newest generation, which I'll loosely, and please forgive my simplistic characterization, but I'm going to talk about Gen AI. Okay, everything else, Gen AI in the everything else category. Telcos are just beginning to get their heads around what that means. Not only the front-facing, customer-facing chatbot type stuff, we understand that. What we are much less familiar with, but the area of great interest is using that technology in actually configuring the network. Nothing to do with interfacing with customers, but when I've got equipment that's been in the network for 10, 20 years, I've got the manuals for it, but it's the manuals that I have to rely on. What if I don't have to rely on the manuals? What if I can interact with the network in natural language to say, actually, you configure the network to do something else, do a different job, and for that not to involve an engineer and a set of screwdrivers and spanners? That's a very, very powerful idea. Which again, because it is such a change in mindset, from software to from hardware to software, and a change in mindset from a manual process to an automated process, and two dimensions, a very radical shift here. So the telecom is trying to internalize that quickly, to learn at a rate that's not used to learning, and to learn about these things from outside, which again is also a little bit unfamiliar. But there's a lot of innovation happening. I think as we see it, what really matters, of course, is what telcos will spend money on. This is all great stuff, and very well in the startup world. How many meetings you have with companies that say, "I love your ideas, but maybe next year," and that, unfortunately, that's still a characteristic in this market. It's helped by the sheer pace of change in and around AI, in and around silicon. There was a point in the past when Intel ruled the world, and we thought, and Intel told us, everything is going to be on Intel chips. It doesn't matter what the device is, it's going to be Intel. Actually, that model is proven to be not quite right, and very far from right. So there's a lot more interest in innovative silicon and ways to use silicon, and the understanding of the different needs of AI. And the AI that you need, as Doug's indicated, out at the edge, for very specific use cases, are very different than the AI you need when you're training, using large language models and so on. So again, a lot of variety in there, and that's part of how things are expanding and growing. So we are seeing shifts in the behavior and the purchasing behavior of telcos. We are seeing, I think, a willingness to entertain some of the newer ideas, even some of the newer companies, but it will take time. It will take time for that to come. I think in the RAN space, something like 95% of the spend on RAN is with 5 companies. 95%. That's 5% for everybody else in RAN. So that's going to be a tough one. I think it's better than it used to be, but you have to go back a long way before you find that that's more than 5%. So anyway, there's some geopolitics in there, go maybe we'll touch on, but maybe not.
I see you nodding quite vigorously, Dan, so I might pass the microphone to you if you want to add from Samson's perspective.
On what? I mean, I could talk about most of that for the rest of the hour. Yeah, so the great thing about a mobile network or a telecoms network in general, particularly as it's become more built around software, is that there is data everywhere. You know, everything is generating metrics, everything is generating information, which you require to be able to manage the network. Even in a conventional network, there was exposure of all of this information to a layer, which then a management system had to make understandable to somebody sitting in a network operations center so that they could see that a specific cell had gone down or a route had gone down, or that something was about to go bang in a server somewhere, which would be service impacting. And what the application of AI, even at that layer, has given us is exactly as we were just hearing about. The ability to, using natural language, actually ask the network, ask it quite huggy, soft questions about how it's feeling, and you know, genuinely kind of say, oh, you seem to be struggling here. Can you tell me what the problem is? And you get natural language diagnostics back. We had a really nice demo at Mobile World Congress, which unfortunately we branded as Copilot before Copilot was a thing, but it was essentially to be able to do that. On the other side of that, at the same time, you also have AI being implemented into the network to optimize its performance autonomously without that layer of human interaction. So there was a mention of anecdotes. The first thing that we did in SI UK around this was in about 2019, and we looked at how just simply to turn more bits of the network off more often. So if you think about the centre of Bristol, or more extremely, the centre of London, when people go home at the end of a working day, a lot of the network is redundant, and so there is a capability on existing network functions to simply turn bits of the network off, save power consumption. But it's implemented very conservatively because operators don't feel that they can run the risk of suddenly there being a big event and lots of people flood back into an area. So we applied AI to that problem to do cell-by-cell analysis of what load looks like, and also to be able to detect if load was going to increase quickly so that you could bring bits of the network back up. And it was great. I mean, we got some great case studies. It was implemented in Richardson with Verizon. It saves about 25% of power consumption across the center of sorry, not Richardson, Rochester, New York. However, when we first tested it, we noticed that it didn't work exactly as we thought it would. So when you want to turn a piece of the radio network off, first thing you have to do is move all the subscribers onto a different radio band, then turn it off. And all of the subscribers kept going back. And that was because, unbeknownst to us, there was also another AI, which had been developed by our sister research centre in Toronto, which was trying to do load balancing. And so every time we pushed devices off of a radio band so that we could turn the radio band off, their algorithm looked at it and went, why are they all there? We should be load balancing across the 3 radio bands, and pushed them all back again. And so they conflicted with each other. And out of that came the nexus of the idea that even if you don't have the AIs working together on a single optimization problem that takes into account load balancing and the desire to save energy, you should have a layer in the network where all of the intents of the AIs are understood. And so you can prioritize, you can see where there's going to be conflict, you can work out what the compromise situation is to get to. So that is the 2 first things that were implemented on Samsung products based on AI's functional optimization, and they immediately caused a problem. Now, if you think about how complicated, what Doug isn't telling us about because it's in dark mode at the moment, but how complicated a RAN device is, or a RAN domain is, when you've got lots of cells, lots of bands, maybe functions sitting in different servers, there's a lot of applications of AI to sit there, and there's a lot of trouble if you don't get it right. So you have to have that idea that all of this AI needs to be coexisting and acknowledging each other's existence in order to get you an optimization out of it at the end. And I guess that's kind of the next stage in the discussion.
I really like that example. I don't think I'd heard that before. That, yeah, AI is fighting each other.
Yeah.
The age of the Terminator is here.
Well, yeah, but I mean, we kind of see it, right? So it's also, it's like a very specific anecdotal example of places where ChatGPT gets answers wrong. Now, when ChatGPT deludes itself into providing with an answer, which is fundamentally wrong, it's because something inherently within it has led it down the wrong path. It's resulted in something being inherent in the model outside of the domain of our control, which says, this is the answer to your question. And you read it, and because we get so engrossed in the idea that it's right, we kind of acknowledge it. And sometimes it's clearly wrong, but other times it's just on the edge of wrong. And that leads you down into all kinds of dark places, particularly if you then agree with the answer and it reinforces the model again.
It's quite telling that there's not quite fundamental, but quite instrumental questions that are still not quite answered, that we're still trying to solve. I was going to move over to Shadi and kind of hear what she's thinking about. What are kind of the challenges that academia is thinking about in telecoms at the moment? What are you working on, and not necessarily right now, but what are you thinking about?
One of them is exactly in line with what Dan said. I would say fighting of the AI models, something, also the conflicts AI models that, we faced the issue when we were analyzing the data or analyzing the outcome of the AI model. Sometimes they conflict with each other. We need to troubleshoot that. The other thing is the data set, because what I would see, the AI models need very accurate data. But I would say sometimes there is a lack of good data that has considered all the important features that are needed in order for the AI to be trained good and has a good performance. Like sometimes maybe if we have one objective and train our AI models based on that only one objective, this is good. But then sometimes there are more than one objective, or there are some features that, the mix of these features together will be helpful in order for AI to get the best results. So sometimes when we have like a public cloud and then we want to run our models there, then we may not have those all of those data that are good for us. The other thing is that sometimes in academia, they may not take care of privacy a lot, and then we just get some data, gather data, and then train our models. Oh, the performance is 99%. But then when industry wants to use our AI models, they may not be able to use it. Why? Because the data set that has been trained need to pass a lot of privacy things. So then, for example, we use federated learning, for example, in the hospitals, then we couldn't share or expose the real data set. Then we try to see how we can train our AI models considering or taking care of privacy of the data set as well. So one of the challenges is this, that we need to take care of that, that what is the data set, if it is private, if it is public, if it is not, then how we can make sure that the privacy is fulfilled. The other thing is, I would say, is about the MEC, like edges, that sometimes there are a couple of edges and then the cloud, and then we need to make sure that, for example, if the users are somewhere, and then we need to make sure if the users are using some applications, then the required performance are fulfilled. Then we need to split the services and models across these edges, and then we needed to select these edges, for example. So this was another challenge for us, how to find the best place to place the edges. Place the services or AI models across the edges that we had. And the other thing that I mostly focus on was the profiling and then finding the relationship between the resources that we assign to the services or even AI models and the performance that we get. And then based on that, we generate a profile of the services. And in this profiling, we understood that if we consider only one feature, for example, it may not be sufficient. So we needed to consider all the features and then find the correlation between the features. And then machine learning models really were helpful for us to find this correlation and then find or select the best features that are good for us. This was another challenge.
The data point I find quite interesting, and Robert, I think you have quite a few ideas about the democratization. Thank you, Dan. I should have had another coffee. Yeah, Robert, can you?
Yeah, I mean, it's one of the areas. So I think in the telecom community, it's becoming much more alert to and aware of the dependency of AI on data, and not just the availability of data in a raw sense. Something like, from what I understand, something like 7% of effort on AI projects, machine learning projects in general, just goes on data preparation. Last 20-30% is the clearer part. Up to that, it's just cleaning it and figuring out what's missing, understanding its provenance, understanding the gaps. How do you fill in? Where do you correlate? Where do you extrapolate? All that kind of stuff. But around that, I think, in addition to the privacy question, the questions about how data is managed, lifecycle management, governance, who's allowed to see data, who's allowed to use data, how do we keep it, and then the other issues around scale. How long do we need to keep this for? What's the set of data we actually need, and what we throw away? There's a temptation to keep everything, and in fact, from an operational point of view, that's a terrible approach because you almost never need everything. You rarely need everything, but you need one or two specific pieces of information. So I think there's a whole ecosystem developing now around data management, just that sort of data fabric. It's not doing anything smart, if you like, but in one sense, but bringing data together. I think the other word that we're seeing a lot more of, it's not a new word, it's an old word, but it's finding fresh currency, is this word ontology, which is what the hell does data mean? Or does it relate? How does it relate to itself, essentially? It might look like it's supposed to be the same thing, but particularly in a sort of multi-vendor environment, which is what most telcos have, how does the same data from from Nokia equipment, how does it behave differently from the equipment from Samsung or Huawei or Ericsson? It's supposed to be the same, it's standardized, but the behavior is different. So how do you correlate that into a data set, even before you do something clever with it? So that's another standing issue in telecom networks in this area of data and AI. So what we're seeing in some senses is an expansion of the problem space. Again, to be slightly more simplistic about it, telcos like the idea of giving a big equipment vendor a large contract, 5, 6, 7 years, a large amount of money, better than the billions, to sort the problem out, to go and fix it. Now what we're seeing is that problem is fragmenting in front of them. There's many more issues to solve. Some telcos are taking that back internally. Some are seeking through things like Open RAN to kind of break the problem apart into more pieces and give it to different vendors. But they're also very keen where we need to hold on to the issues, because we let go of that for 10 years. We gave it out to the vendors and said, you sort it out. And actually, vendors didn't always build networks in the most optimal way, or don't necessarily bring that expertise back in-house. I've seen that firsthand. Telcos who don't understand how their network is engineered. Their job is to run it, but they have no idea why does traffic take this route and not that route. So they're kind of nervous about that as well. So there's, I think, a large extent which they're trying to reskill and skill from the inside out where they can. But the data question is one that is very current right now. Your point about conflict, again, is one that I think everybody working in this space is aware of, it's something that often causes vendor pitches to kind of stumble slightly, because the question, I know you've got a great, in the case of Open RAN and RAP, these sort of small applications that sit on the RAN or working with the RAN, RAPs and XAPs. The XAPs are kind of fast, super smart stuff. The RAPs are so slower thinking things. But the question is, what do you do when there are 2 or 3 of these things? And very, very simple. I was on a call with a big vendor yesterday that said, we've got 26 of these different RAPs. They have no idea how to regulate them. This one does power efficiency. This one does performance. And just to take those two as a very simple example, and these are not unknowable examples. These are very straightforward. Do you drive home the fastest route, or do you drive home the route that's lowest fuel consumption? Whether you're electric or petrol doesn't make any difference. It's a very simple kind of dilemma. And the answer isn't one or the other. The answer is usually a combination of both, except for when it's one or the other. And that's the problem. And so back to a point that Dan made, which is very, very important. I think when it gets to the topmost level in telcos, driven by very, very simple ideas. Assure the service. Think 999. Okay, that's the question. Our networks are regulated to support 999 services. So don't do anything that is going to cause my 999 service to be degraded. I may only need it. One call in 10,000, doesn't matter. Don't do anything that affects that. And so one of the mindset shifts for telcos, I think, is around some of these ideas around automation, autonomy. How do you prove it's not going to degrade my service? Very, very difficult to do that, but it's a concern that's there. I think there are ways to do it and reassure, but it's very much a proof point. Even if I believe what the AI is doing, believe the benefits, I'm going to bring it back to, am I letting that live in my network or not? And the conflict thing is one of those. But let's say data. Back to the question, the data thing is occupying a lot of minds right now, precisely because there's so much data available in telecom networks. Time was that networks we kind of told, the device is told every 15 minutes. How are you doing? Now it's seconds, and it's not the same data. So now it's log file changes, triggering event to say my configuration has just changed. What do you do with that? And you don't do anything with it unless something else happens. So how do you correlate the log file change? Maybe it's a pattern of behavior over time. Incredibly complex, and again, vast amounts of data being fed into platforms, and then from platform into the actual AI parts of things, the real AI parts of things, back out in a loop to say, actually, just adjust the network this way or that way, tilt it left, literally, tilt it up, tilt it down. That's the level of control that we're talking about, and the concept of that is still somewhat challenging for telcos. Telecom likes to engineer things. Those of you who live in the IP world, which is actually all of us, will understand how when IP kind of hit telecom first time around, telecom said, that's brilliant, we love that, but can we just fix it in place and just lose all the actual benefits of IP and flexibility, just call it MPLS, bolt it all down so you've got some flexibility, but not too much. And that's kind of, we're potentially at that point in AI, I think, which is where telecom kind of constrains it. It says, I love your power efficiency application, but can you just do it just in this one area some of the time, when I ask you to, which is, again, losing the benefits of autonomy, losing the benefits of self-learning systems. Sorry, that's a bit of a rattle.
Yeah, no, it's fine. Dan, I think Dan's desperate to comment. I'll let him comment, but I'm going to open the floor to questions in a minute as well, so you get some time to think of any if you want.
Yeah, I mean, the challenge with the application of AI into networks is that the entire network is a compromise, and that's kind of what Robin was saying, right? So even on the air interface, you're permanently in the decision about compromising coverage versus capacity. So you can make yourself smaller, increase capacity in a space, but then you'll leave a gap. If you make cells bigger, then cells interfere with each other, and then you impact capacity. So you're in this compromised situation just in terms of planning the RAN, and then in terms of planning the backhaul networks. Backhaul networks, you can throw lots of bandwidth at things. Unless you own all of your own fiber, you're paying for it. So then you get into the world of arbitrage, choosing cheapest route, which might not be a route which has quite the right amount of capacity, but you have to use it because of the time of day. All of these things you can apply AI to. And this is the point. The data which exists within a network should give you the power to optimize against all these things. Bigger challenge is that, yes, there are standards, but particularly in the management layer where data is exposed, those standards are flaky at best. They have been the source of considerable contention because they result in vendor lock-in. So you can have interoperability between your RAN and your core or an open RAN, but if you don't have interoperability on the management layer, you end up in a situation where one management layer controls everything and it's impossible to churn anything out, and then you're stuck. And the other thing is that because the data associated with operating a live network is operational, operators don't like to expose it. And one of the great early applications of AI was meant to be for anomaly detection. When you spot something in the network, which is that little blip, which goes, oh, that's indicative that something else is going to go wrong later. and you want to spot it early. So you spot the anomaly. If you get a very limited data set from an operator to use to do research against, one of two things happens. There's either no anomalies in it, or there's one anomaly in it because the data set is so small, the anomaly is repeated because you have to keep training against the same data set over and over again, and it's not recognized an anomaly. It becomes a pattern. So what do? You need access to real live operator network data to do research against. Otherwise, when you try to apply your nicely trained ML or AI back into the network and it encounters real data for the first time, other things happen that you're not expecting, and your trained model is wrong. So that's one of the biggest research challenges, just getting data out of the network. There is one big data set which was revealed by Telecom Italia a number of years ago. You could open academic papers, read the first paragraph and go, that's based on the Telecom Italia data set. Everywhere doesn't look like Milan. Sorry, Andre.
Awesome, thank you. Doug, go for it. No, go for it.
So there was just one point that pulling a couple of strands from what you started to talk about, standardization, and your comment about when IP hit telecoms. I think there is a AI hitting telecom problem, which is to do with standardization. I mean, it's well known that every 10 years you get a new G. I mean, these things wouldn't exist if it hadn't been for these things wouldn't exist if somebody didn't write down in lots of excruciating detail how they're supposed to work, so that if you take different equipment, different handsets from different people, they will work with stuff from other manufacturers. Now, there is a fundamental problem with this 10-year cycle. Well, there's lots of problems with the 10-year cycle, but the thing is that's a very long time scale. AI doesn't play like that. It's if you think about innovations in, I don't know, physical air interface processing in the last 2 to 3 decades, it's probably 4 or 5. I mean, you've got your massive MIMOs and your turbo decoding and what have you, but they don't come along very often. So a 10-year cycle is fine. It's hard to predict what's happening next week in AI, let alone next year or over the course of the next 10 years. So yeah, I know that 3GPP do an upgrade every year where they tweak things and add small numbers of features here and there, but that's standardizing how AI is supposed to interoperate is a significant challenge, and I think there's a lot of work to be done to figure out how to do that. I mean, I've heard people stand up and say, oh yeah, well, we should actually just specify the model. It's almost to the level of saying it's a convolutional neural network and it's got this many layers, and it's like, no, stop. So there's a lot of work and thought need to be put into how that can happen and make interoperable equipment.
I'm going to check if there are any questions. I think we've got just under 15 minutes, and I want to make sure that we have time. Yeah.
It was pretty your talk. I think what I've taken away is that AI makes the networks better, cheaper, faster, but for minutes. But how does that change the telco business? Yeah.
Okay, so is that okay? Right. Yeah. I was just saying. I was launching.
It's quite different.
Yeah. Okay. So how does? I'll repeat the question. How does AI in the network improve the business model? Right. So the business model for telcos is a bit screwed at the moment. Revenues are flat. We're over 100% penetration. ARPU isn't going up, even despite new Gs. So 5G didn't really present an ARPU uplift. It just meant that I got to sell lots of new shiny phones. Thanks for that, everybody. But the big thing that 5G was sold on wasn't about consumers. It was about B2B. It was about opening up B2B business opportunities, being able to add connectivity on top of things like connected vehicles, IoT, healthcare, industry, bringing, ironically, data out of all of these other industries and exposing it and being able to communicate it to other places where it has more value, being able to consolidate, being able to train against that. 5G has so far fundamentally failed to open B2B opportunities. And I have a very strong view that the reason for that is because you're trying to take a network which is doing a pretty good job of serving consumers with a service and apply a B2B based SLA on top of it. So if our phone doesn't work, what do? We try and attach the Wi-Fi if you're doing data, or you go outside and you try and make a phone call again and you swear a bit and you move a bit further and you press the button again and then maybe it works. We don't go and sue people. If you are connecting BMWs and they're all going along the motorway and they all become disconnected and it impacts the service that the driver is receiving within the BMW, first of all, there could be a very large nasty accident. But secondly, even just the service going down, even if it is not mission critical service, BMW ring up the operator that provides their network and says, what the hell happened? This is how much you owe me. So being able to use AI to optimize the design of a network in specific instances to meet SLAs is where we need to go. We need to go to the point where we're not tied to a 3GPP architecture, which clusters bits of functionality together in big lumps. We have to properly embrace softwareization, and then we have to go one step further and properly embrace the way that IT builds networks to enable things which take the SLA as the underlying principle and delivers that over the air interface. So it requires a fundamental rethink in the way that networks are designed, but AI sits at the center of that as well. And again, I'm going to point at Andrea over there because we've been trying to work out how that works for the last 2 years.
Yeah, Robert.
I just want to offer, to answer your question quite directly, it doesn't. It changes the operational model massively. Operational model completely transformed, along with all the other things. There's an immense amount of soul searching going on within telecom right now. What the heck are we? Are we connectivity providers? Are we digital service providers? What is our future? For exactly the reasons that Dan's described. In flat revenue, we're pretty much, saturated in almost every market. Where do we go from here? There is potential for creating a sort of longer tail. Instead of telecom being in the sort of you build a standard product and that's what you get, everybody, to offer much more granularity to serve much smaller markets. Again, this is counterintuitive for telecom because it's built on massive scale, national scale. But if you can find an economic way to serve much smaller segments, even transient segments, a simple but bad example is the sort of Glastonbury Festival type thing. Imagine every festival could afford to have a pop-up network that worked really, really well. Your local village festival, town festival, Bristol Harbour Festival just pops up. There's a price for it. Maybe it's £10,000. But the point is there are thousands of them across the year. That's an interesting, it's not a change to the business model in the sense you're describing, but it's definitely a different way to make revenue. And if you can scale it, that is really the key point. That's what I mean with the long tail in telecom. There is discussion around the use of term they use is AI RAN, around the idea of reselling compute capacity that's out of the edge, like that's describing. It's quite a controversial idea, controversial in the sense that there's a wide diversity of opinion from this will never work to this is the future of telecom and everything in between. I'm not going to try and call that one today. That's probably another. But that's, I mean, arguably that's not really a new business model. I will, if it indulge me for 1 minute, my own analogy for this in trying to think about this question, because there's a lot of technology involved, is what I call the car park analogy. Imagine if every RAN had a small car park, okay, that telcos owned. Would it be a business model to say, you know what, we only need that car park when the engineer comes to do something in RAN. So the other 95% of the time, we're going to rent it out. Okay? Problem with that, of course, is that requires a whole infrastructure of systems to manage contention. What happens to book for it, to monetize it? How do you charge for it? Maybe you charge different times, for daytime and nighttime. So you have 24 hours. And then what do you do when there is the ultimate contention, which is the engineer has to get to that RAN location? I'm only using that as an analogy to say, how should we think about AI RAN? Another, what is essentially a physical resource. It's very valuable resource. But we need all the same things, but even more so. Is that going to make money in that way or not? Just posing the question in an analogous way to help us understand how to think about the problem. Some telcos will say this is a great idea because they've got lots of real estate and very low traffic. Others will say it's a great idea. Urban sites are far too valuable for us. We really need pretty good. So it's going to be a context. But that's back to your question about business models. That may be a route for some, but not I think for the industry.
Cool. Hopefully that answered your question. Have we got any other questions from the audience? Oh, yeah, over there. Okay. Yeah. What do you think about the dependency on NVIDIA chips?
I mean,
It's
you
a
have,
big question.
you have to take your hats off to you have to take your hats off to Jensen. You know, they've done an absolutely stellar job. I mean, you know, can't argue with the stock price. We probably could, but the you know, they create some, you know, enormously you know, powerful number crunchers, and they chase after the biggest and ugliest problems with them. Yeah, they have a range of products, all the rest of it. But I think the thing is particularly when you start to look at embedded AI solutions, you know, you need to start thinking about have I got the right amount of computation capability? Have I got the right interfaces? Have I got the right storage? Have I got the right companion host processors and what have you? I think the thing is, it's if you're making a chip for a specific application rather than just a general super high performance number cruncher, you have to think of a lot of other things, which is not what NVIDIA do. So, and particularly, you know, in that embedded space. And they also a lot of the things that they do are not necessarily what I would describe as real time. ChatGPT is biological real time. You know, it depends on how fast you respond to it. So as long as you feel that the answer's coming at you fast enough, I mean, you know, if you're interacting it with the terminal, then latency and throughput aren't too much of a concern. If you think about base station, which is handling, you know, gigabits per second, and need to worry about sort of, you know, micro millisecond timescales, it's a very different problem. So, you know, it's kind of like it's like, you know, Intel make great great processors, and they're great for certain classes of applications, but you wouldn't use them for I don't know, controlling a washing machine, for example. You know, it's just to sort of give some perspective. So I don't know if that answers your question.
So it becomes a question, and again, it's analogous to a lot of things in telecoms. It becomes a question of scale versus necessity. So, yeah, we had the discussion about Gs previously in the standardization 10-year cycle. I fundamentally disagree with the whole trope around Gs on the basis that the telecoms network, the mobile telecoms network today delivers 2 services and one which it delivers by accident. So it does voice, it does data, and then SMS was never meant to be a consumer service, but it became. And if you look at the actual cycle that we've gone through in terms of that as revenue streams, there is only that. There's voice, which peaked and is now in decline because you do voice separately. There's data, which continues to escalate, but the revenue has flattened, even though the volume continues to go up. And there's text, which is all but dead, although it's trying to reinvent itself in other spaces. But the reason that there's only those 3 is because everybody uses them. Every phone that we have in our pocket supports all 3. Yeah, and the brilliant thing is it supports all 3 in exactly the same way. Otherwise, we couldn't send text messages to each other and send text messages to the other side of the world and make a phone call and all connect to the internet in the same way. So that scale is great until you get to the point of saying, okay, so just as Doug says, we don't want it to be a voice call where you've got 150 millisecond latency. You've got a sensor which needs 1 millisecond latency. And then you have to optimize not just the device, but the entire network in a completely different way, which doesn't match up to the huge consumer network that you're already dependent upon for revenue. And you either have to spend a lot of money to implement that optimization, or you ignore the opportunity. And the opportunity comes with risk. And the risk is the thing which means that all of us geeks, and I'm including you because I know who you are, all of us geeks who like the idea that we can deliver the service are not the people who make the decision. The people who make the decision are the lawyers and the economists and operators who look at the opportunity and look at the risk associated and go and say, there's absolutely no way we're going to sign that contract. And that's something which we have to get over. We have to find a way to get to a point where you can design a network which coexists with your consumer network in a way that doesn't make it too risky to implement and then has sufficient revenue associated with it without risk to justify the business case.
Simon.
Some of the Bristol innovations. Some quick fire round for the panels. We've heard about who's not going to win out of this, but let's suspend disbelief. AI Telecoms Convergence is going to be the next big wave. Which companies or organisations do the panel recommend that we watch? Who's going to do well? This convergence of AI and telecoms.
Okay, so who's
I don't want to hear NVIDIA.
which companies, organizations are going to do well out of this, other than NVIDIA? Do you have an opinion, Shadi, as an academic?
So you expect that we name a company here?
Yeah. Well, I'll take the category of company as a second choice.
Fair enough. Dan probably has a opinion.
Well, so the reason it's hard is because I don't think they actually exist yet. Because I don't think there is any companies, with the possible exception of NVIDIA and other people who are operating in that space, who are well positioned to exploit this yet. And that's one of the challenges that we have. So the company which does well out of this is the company that gets to the point where they can de-risk this. And it's all risk because it's all future. And the de-risking part is the bit which presents the opportunity.
Yeah, sure.
The other thing that I'm thinking is that, the performance of AI models really depend on the technologies that we use. So maybe a company is using some technologies, but the other company is not using that one. And then if they say that, okay, so these AI models, we support these AI models, or we provide these AI models, and we can converge it in the telecoms, but then we cannot get those results. So, and we see this in a lot of different layers in telecom, like in RAN, for example, the XApps. Some companies just say that, oh, we have designed these XApps, and then we cannot use them because they are not compatible with the technologies that we use in our testbed, for example. So really, I think we are not at this stage that we really say a company that, oh, whatever that they have, whatever product that they have given us have the same performance that they really promise.
Okay. Doug, is it RANsemi?
So Simon, do you expect me to say anything other than RANsemi?
I think Dan's right. We're at this transition phase, and so all the work is going on, all the experimenting, all the exploration is incredibly valuable because this is an industry that has to learn very fast about how the world will work. I think the point about one point I want to kind of overlay what Dan said and Shadi as well is it's about scale. That's how the telecom industry, the whole economic model of telecom works only because of its scale. And one of the challenges that we see, one of the frictions we see in the industry today is between the telcos and the traditional telco supply chain that thought it had scale. And then the hyperscalers come in and say, oh, you think that's scale? Then we show you real scale. And I think the friction point in between those two is around data, actually. So the companies who do well are the companies who can leverage the hyperscale tooling with the telecom specific. I know that's a bit of a cliche, but that's where the most important interface is. Because just coming in one or the other doesn't make you successful in telecom. It may make you successful in other areas. So I think that's the interface. Everything around data, the ontology, the processing, but doing it at scale in a way that telecom can swallow easily and say, yeah, we believe that. I think that's where the real kind of vector of growth beyond where it is today.
Remember, that was a serious slogan, was it? Nothing as hard as air. That was
yes, no, I just want to add that I am from Palo Alto, but my previous role has been with DCID, where it's funding four of the and running actually four of the AI projects which DCID kind of funded, and what we noticed is that And the reason why we did that was to develop that business case. It's a shame that we've run out of funding and the rest of the reason I lost my job early this March. So you can imagine now for 4 years of advising research. But it was to actually see how competing projects working on very similar algorithms come up with different answers. So if you look at the energy efficiency, if you look at spectrum efficiency, there were 4 projects actually doing the same piece of work, but we were getting 4 different answers from universities. It was the XApps and the RApps which were being developed, say from the University of Edinburgh, working with Microsoft, Intel, Capgemini. It was very different to what Dimitra was doing in her lab, or what, for that matter, the other project, the RAN project, or the towards AI project was bringing together. So we were getting different results from different companies. Again, when you put all that together and you do an analysis, and I'm hoping that somebody in that at the end of all these projects, we would then be able to form that business case, because there are companies like we were involved in some of those pieces of work. So naturally, we are there because want to see how that will behave and how that can be implemented in the network. So which that is actually there in one of the projects. I'm not sure what the reason as well. There was an operator, right?
Yeah, it's a reason.
Yeah. So again, those companies at the moment, are some of the YBs and the Amdocs and Capgemini of the world. They have internet at the moment, and how they will do that and the operators is where it's going to go. That's all I get. That's all I get.
Well, quickly, yeah.
So I wanted to, yeah. Oh, that's right.
Yeah. We'll take one more question, and we're going to wrap up because we got or 2. Yeah, but we'll start with the lady in the orange jumper.
Thank you. Doing dangerous things. I'm really curious about the conversation that I've been listening to that links to risk and assurance of safe operations that you risk aversion, because they have to make sure the 999 works. And I'm curious to what extent, in terms of AI and telecoms and where these intersect, are people looking at other sectors where they've got a long history of making sure that automation doesn't fault in a safety critical system, so aeroplanes and things like that, and whether or not some of those lessons that have been learned the hard way in those other sectors and those practices, so for example, the use of safety cases as a way of sort of clearly demonstrating that a thing in this wider system, its purpose, being able to argue that through. Are those lessons and that good practice being pulled through into these new emerging sectors to sort of tackle and de-risk some of the things we talked about? And I'm seeing.
That's fine. Just quickly for the recording as well, because we don't have a mic. So in what lessons can we learn from other industries, or safety critical industries like aviation, in terms of automation?
So that's not the question that was asked. The question was, are we learning the lessons? I said, so what lessons could we learn? Lots. Are we learning the lessons? Absolutely not. And I say that based on a much broader problem that we have in telecoms, is that we talk to other industries like we know what they do. We refer to other industries as verticals, which is highly pejorative. We don't take into account what their business model is. We just assume that ours is more important. And as a result, we sell our value to them rather than looking at what value we can add to them. And I quite often point out that, in any B2B business relationship, the price of the first B is a cost and the second B is business model. So immediately we go into B2B, whatever our price is going to get squeezed because it's impacting their margin. And then when it comes to your point, the risk I was just talking about is business risk, not that literal risk. When we start to talk about literal risk, again, we take a very telecoms perspective on it, and we go, well, 5 nines is a metric that we use for PLMN availability, telephony availability. So clearly, people who've got highly critical services, they want 6 nines, 7 nines, which is great, except that it's not 100%. There's still a 0.0001% chance that something goes wrong, and that's when a plane falls out of the sky.
Yeah.
But I mean, just to add to that, sort of extrapolating the point that Dan made a bit earlier, maybe wireless telecoms, as opposed to telecoms in general, has probably always been able to hide behind the fact that actually wireless is really, really, really hard, like really hard. You know, I used to say to sort of friends and family, don't complain about your mobile bill. Do you know how completely difficult this is? How to get waves into buildings through these stone walls? So even though the equipment might be 5 nines, 6 nines, however much reliable, the air interface is not and will never be so.
Yeah, I just want to, not to be kind of cheesy about it, but I absolutely want to reinforce your points about telco not learning from it. It's one of the great ironies of the telecom industry. I go to events all the time with telecom executives, and they have no clue what's going on in other industries. They don't have a concept of it. And at the same time, they're saying, well, where's our value? How do we, to Doug's point, how do we get more? What we do is incredibly important. Why don't people pay more for it? And I think the safety one is a very good case in point. Not least because it points to another question that's asked earlier about business model. I think one of the big opportunities today is the connection of multiple technologies at the same time, and specifically around safety. You can definitely make a value proposition, I think, on building sites, on driving. The autonomous vehicles thing is a red herring. But are there things that you, as a telco, can do with other software providers, with other with video analysis companies, that will make it safer to be on the roads? Absolutely, but you've got to piece those pieces together. And I think making it a safety play, I mean, that freaks telcos out as a concept, but there's obviously opportunities to, every time you've got heavy machinery or people or crowds or remote locations or dangerous locations, there is an opportunity. If there's risk, there's an opportunity. And I think connecting together this amazing technologies that we've got, there was going to be a question. We were going to talk about the impact of AI on networks. Dan sort of mentioned it sort of in passing. Telcos have no idea, is the short answer, about the effect of AI on networks. My point of view is they're missing the point. And if the result of more AI processing, and I mean the kind of Gen AI side of things largely, is to create more video traffic, if more of the devices that are out there are sending videos to somewhere else to be processed and understood, that's an indirect effect on traffic. It's not AI traffic, it's video traffic. And video traffic just kills things horribly in a telecom network. But there is an indirect opportunity, and AI is part of that. That's what I mean about putting multiple technologies together. A safety play based on visual inspection, real time, and even through to control the device so that it doesn't drive that extra 1 foot that's going to cause them an injury. But that relies on telcos getting much closer to some of those, again, a horrible word, the verticals. Nobody in the vertical industry said that. Vertical industry. Only telcos use that word. But I think that's a definite opportunity for telcos to expand and explore. So I hope your background and expertise will find its way back into telcos because it's sorely needed and it's a great opportunity.
Right. Do we have time for another question? Yeah, we'll do one final question because I promised it to you earlier anyway. How would you? Well, that's a question for Shadi, I guess. How should lecturers upskill their students?
I'm the customer.
Yeah, I'll go. Yeah.
So probability theory, right? AI probability theory. Don't train them how to use TensorFlow and all the rest of it. Go back to basics. Like if you want to teach a good engineer, teach them maths. You know. You know, it's kind of like back to hardcore hard stuff, because to do that, the problem we have is telco's not very sexy. My son has a first-class degree in computer science and AI. He works in football as a data scientist. There's no way he touched telco. Yeah, he gets the travelling jets all the time, so it's very hard to get in. You have to work really, really hard, like stupid hard.
Maybe that should be the next event, the critical convergence of football and AI. Shadi, do you have any?
So, we need to know what are the industry requirements. So it's not only that we teach the students, these are some theories, and you just design your models, your AI models, and then we don't consider what are the industry requirements. So I would say the research projects has a very good role here, because when we are contributing to research projects, big research projects that has industries, SMEs, and the academia, then we understand more what are the requirements that the industry needs, the future world needs. So, we should not only say what is the current situation, we should oversee what are the requirements in 10 years, which is very hard to forecast from now because it's changing in minutes. So I would say the lecturers, if they only have experience in only the universities, they won't have the students that the world needs them. So they really need to have collaboration between, the industries, and then train the students in a way that are useful when they are graduating.